Hello students, welcome back to online physics classes. So with the same kind of positivity that was during the starting of this first part, we will start this part also, knowing that yes, we are very much stuck up in this lockdown. So in the first part of the video, we have discussed regarding the very basic directly related phenomena and observations, theories related to gravity, the universal laws of gravitation, the acceleration produced during this gravity. We have calculated both the values of g, the universal gravitational constant, the acceleration due to gravity. We have used g in terms of a in the natural laws of equations of motions. In this video, I shall try to discuss some phenomena, and we will try to relate those phenomena with the effect of gravity. So, and those some principles like this Archimedes principle. In this video also there is a story regarding the discovery of this Archimedes principle. And in the last topic, the relative density, I shall try to show you a solved numerical problem based on relative density. So without delaying, let's start the class. So after here was some direct calculations of gravitation. These now topics are again we will be relating some observations to the theories of gravitation. Now two scenarios are shown here. Suppose we are standing on a sand. What happens if we stand straight on a sand? Our legs go deep into the sand, and on the same amount of sand, if we lie down, then nothing happens. We just keep same over the surface. Why this happens? What is the reason that if we having same kind of weight, same kind of mass, if we stand straight, then we don't go downwards, and if we lie down over that surface, we just don't go downwards. Whenever we are standing straight, there is a chance that we are getting down. We are getting stuck onto the sand, and when we lie down over the surface, then nothing happens. The reason behind this is what led us to some terms to thrust and pressure. So we have to know about these two terms, thrust and pressure, to have a clear idea that why when we stand straight our legs go deep down inside into the sand, and while we lie down on the sand nothing happens. We just stay calm and quiet over the surface. Thrust is the force applied on a surface in a direction perpendicular to the surface. So while we are applying force, while we are standing, we are actually applying force. Now why I say applying force? If we are doing nothing, if we are not own self applying force, the earth is attracting us, the earth is applying a force over us. That force and as a reaction of that force we are giving a reaction force to this sand. So when we are applying force, this force is directed perpendicular to this area, and this area is smaller, so here is large amount of thrust. And see, the effect of thrust per unit area is called pressure. It means pressure is thrust per unit area. If the area increases, pressure ultimately decreases. So means here was a smaller area, so when we are standing straight, the amount of pressure was big, and when we are lying down we are actually making our body contact with the surface, so the surface area is increasing. So for the larger area, thrust is getting decreased, smaller thrust resulting in smaller pressure. So while we are lying down, there is no movement of getting down. This is difference regarding this thrust and pressure. Thrust is the force that a body exerts perpendicularly on a surface. The SI unit is Newton. It's numerically equal to the object, because suppose we are taking our example. When we are standing on the sand, the weight of our body, that the by which the force by which the earth is attracting us, that is the force that we are applying to the sand. So that is the amount of thrust, as because the surface area, the area of contact is less, so it's numerically equal to the weight of the object. Pressure is the thrust or an unit area. For an unit area, whatever the thrust is, it's called pressure. So if the area increases, the thrust becomes decreases, and so if the area increases, the pressure decreases. Its SI unit is Pascal. So now, as we have started discussion something regarding pressure, so we will be discussing something in short, pressure in fluids. Two properties that I will mention, that pressure is same in every direction in a fluid at a given depth. It means at a particular depth, the pressure exerted by a liquid in all direction is same, and if the depth increases, the amount of pressure increases. The reason behind this saying these kind of things is that next topic that we are going to start is related to this pressure in fluids. We will be heading again towards an observation. See, we observe in our daily life that whenever is allowed to a body is allowed in some water, then some bodies floats on the water surface, some body sinks. Some body sinks down, some body floats. Suppose you are throwing a stone, a very lighter object compared to a big boat, but the boat is normally flowing over the floating over the river surface. But if you throw a stone to a river, the stone goes down. So what is the reason? The reason is that, as we know that liquid exerts pressure, the fluids exert pressure at some all directions. So water and other fluids exerts an upward force on an object. This force is called buoyant force or buoyancy. This buoyancy is the reason that some body floats over the surface of a river or any water bodies, and something sinks down to the bottom of a river body. Now, first we have to understand, whenever a body is allowed to be in contact with the river body, what are the forces? What are the forces and what are the factors that is responsible? Either the body will sink or float. Whenever we are getting the body into water, then gravity is definitely acting upon it, and this buoyant force which is offered by the liquid. Density of the object is a very important matter. We will be discussing that later on. So this is already, I think it's clear that what is the reason behind some kind of things floats over the surface of water with a heavier kind of area, and some even with smaller areas. Why does it sink down? So these are if the weight of the object is less compared to the buoyant force, then the body will be definitely floating, completely floating. If the amount of weight increases compared to the area, then what will it happen? The body will start sinking. So cork, these are some examples that had been shown. Cork, the weight of the body, compared to the size of the cork, as we know that cork is a heavy, lighter kind of thing. It's compared to its surface area. So the opponent force, the buoyant force, is comparatively large to the weight of the cork. So the cork easily floats over the surface. For wood, the weight is comparatively larger from the cork, so it will be partially submerged. And iron, the weight of an iron is very large if compared to its size, and the water displaced, so this will definitely be going down. Neutrally buoyant means a body which will have the balanced weight to buoyant force ratio. So this buoyant force is, or buoyancy is responsible that a body will be floating under the on the surface of water or not under the action of gravity, because gravity is ultimately acting on all kind of objects. Gravity is always exerting force. So if the gravitational force product to its mass is more compared to the buoyant force, then the body will submerge. And if the buoyancy is more compared to the product of mass and the gravity, the value of g, then the body will be floating. Plus the concept of thrust and pressure is also applied to this concept of fluids. Heading towards the last topic of this chapter, there comes another story. Archimedes was a Greek philosopher. Once he was told to examine the pureness of a gold by the king of Greeks. So he was thinking how to figure it out, but provided with the condition that he will have to identify, he will have to examine whether the gold offered to him was pure or not without destroying the gold. It was said to be the king's crown only. So it was a very big deal how to figure it out, that is it the gold is real or not without actually damaging the crown of the prince. So while thinking something like that, once he was taking bath. Suddenly he realized, and when he was stepping into his bathtub, some amount of water was rising up. Incorporating this observation, he developed a theory. He proposed that if the gold of the crown is real, then we have to apply same amount of gold. We have to submerge same amount of gold to water. If that the water displaced by that pure gold is equal to the water displaced by that crown is same, then it will be sure that the crown has the pure kind of gold in it. So this kind of theories, from this kind of observations, he developed a theory which later become known as, following his name, Archimedes principle. This principle related the buoyant force to the water displaced, the buoyancy with the water displaced, because we know that whenever we are putting something into water, the surface of the water is giving an opposite force to the body. So this opposite force, this buoyancy, the buoyant force, he related this buoyant force to the water displaced. According to this Archimedes principle, the buoyancy or the buoyant force is equal to the weight displaced of the displaced water. If a body is submerged into water, if the body is placed into water, definitely there will be a rise in the amount of water. The amount of water displaced, if calculated, these two will be same. So the buoyancy, which is responsible for the uplifting of this water, and this water will be displaced, the weight of this object will be numerically equal to the weight of the displaced water. This was famous Archimedes principle. As I told you earlier, that there will be an important factor of density in kind of this buoyancy force. So we'll have to read about some densities. Because if a body is more dense, only then compared to its size it will be heavier, and a body, if it's less dense, then if the size is also increased, suppose this case of this iron, the density of iron is much more, so it if all of these have from this picture, all of these kind of things have same sizes, but as the density of this is high, so the weight is high, so it's getting down. The density of this is low, so it's getting up. So the buoyancy is keeping it up. So we will be getting a topic like relative density. What is relative density? Density is basically mass of a substance in unit volume, mass per unit volume. That is known as density. Now what is relative density? Relative density is something, density of a substance compared to the density of water at 4 degrees Celsius, or this is actually numerically it can be calculated or said that relative density is also calculated as mass of a substance to mass of equal volume of water at 4 degrees Celsius. This 4 degrees Celsius is taken as a measuring parameter, the condition for a measuring parameter. So we basically know what is density. Density is mass per unit volume. So substituting density and relative density, we have find that relationship, that relative density of a substance is mass of the substance to mass of an equal volume of water. So basically relative density means density of the substance compared to the density of water, compared to the density of water. Basically density means mass per unit volume, and relative density is comparison of the density of a body to the real density of water at 4 degrees Celsius. This is showing a ratio comparison between density and relative density. Is ratio of mass to volume. It's ratio of density of substance to density of water. Density is the ratio of mass to volume, and relative density is the ratio of density to density, density of substance to density of water. Density is mass by volume, units are the same, gram per centimeter cube or kg per meter cube. It is a pure quantity, it has no units because it is the comparison of density to density, so it has no unit. Density has a unit, kg per meter cube or gram per centimeter cube, but relative density doesn't have any unit, it is a pure quantity. Now this is a math showing some calculations. A question is given that a 250 centimeter cube bottle of oil has a net mass of 189 gram. Calculate the density and relative density of oil and state whether the oil will float or sink in water. Now because the floating or sinking of any object on water depends on the various factors, the buoyancy, the gravity, the acceleration due to gravity is same. So the buoyancy and density are the important factors whether the body will float or sink. So the solution is mass is given as 189 grams, volume is 250 cm cube, the density will be mass per unit volume, m by v, 189 gram by 250, so which gives 0.756 gram per cm cube. Now the relative density will be density of this oil to density of water, which is 0.756 gram per cm cube by 1 gram cm cube. So the relative density is 0.756. Now as this relative density is less than 1, so definitely the oil will float in water. If it had been equal to 1, then it would have been neutrally buoyant. If it had been greater than 1, then the body would have sink. So this means that oil will float on water because the relative density, the value of relative density is between 0 to 1. This is a problem that have been solved on the basis of this relative density. So here up to it was the topics that the direct topics that has been that were in your NCERT textbook. There are many numericals that you have to do for these chapters. We will be making some other classes, going on towards some other classes for these numerical lessons. But before doing numericals, I will again request you all to go through the basic fundamentals and try to establish basic fundamentals of the chapter, like the free fall, the value of G, the universal gravitational law. Don't just read and learn, try to understand. These are very easy, and try to think. You will get many fascinated things while reading these chapters. So thank you. and hope following Sir Isaac Newton, I request you to use this quarantine time positively, with some good hopes of our future that will be doing good. So thank you.